Hello, hello. Get everybody loaded in. All righty, so let's see. Looks like we're missing Zoe Owens, and I think that's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, because we're not going to have Grant today. All righty, so hopefully Zoe Owens will log in soon. All right. How's everybody doing today? It's Thursday. It's a rainy Thursday, but it's Thursday nonetheless. So that's always good. I get my screen going. We'll go ahead and start going over our homework. There we go. There's Zoe. All righty, so let's see. We need all righty, so our homework, if I wrote it down. Okay, so we were working through lesson 19. Okay, so in lesson 19, we had talked about clearing our decimals. And so we started with homework on page 42, those top 4. So let's see, get to my page real quick. I will read out the answers for these 4, and then I will work any that we need to work. So page 42, starting at the top, I will do, we'll go ahead and do on the left-hand side, I'll do the top and bottom. Then we'll move to the right-hand side, and I'll do the answer for the top and bottom of the right, okay? So left-hand side, top problem, x is equal to 105. The bottom one, the one below that, x is equal to, you could either have negative 12 over 5, or you could have written that as a decimal as negative 2.4. Remember I said that when I have a decimal problem, go ahead and write it as a decimal. So negative 2.4. Any questions on the left-hand side? Okay, on the right-hand side, the top one, x is equal to negative 158. The one below that, x is equal to negative 6. Questions on either of those? Awesome. So none of those.
Below it.
I'm sorry?
The one below it.
I'm sorry, which problem?
The one below it, right-hand side.
The second one right here?
Yes.
Okay, so let me go ahead and I'm going to erase.
I couldn't actually look at the problem because I ran out of room on my page.
Okay. All right, so on this one, the first thing, distribute, 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 distribute. So I've got 3 times 0.03x would be 0.9x plus 3 times 0.5 is going to be 1.5 equals 2 times 0.2x would be 0.4x minus 2 times 0.09 is going to be 0.18. And then we have plus 0.3. Okay. Now I only have one decimal point is my largest, so I'm going to multiply everything by 10. Multiplying by 10 moves the decimal one place for every term. So 0.9x becomes 9x. Whoop, where'd my 9 go? Plus 15 equals 40x. I'm sorry, not 40x, 4x minus 18 plus 3. Now that I've got those decimals cleared, I can go ahead and combine like terms, and I see I've got a negative 18 plus 3 on the right-hand side. So I've got 9x plus 15 equals 4x, and then negative 18 plus 3 is negative 15. I want to go ahead and move my x terms to the left-hand side, so I'm going to subtract 4x from each side. 9x minus 4x is 5x plus 15 is equal to negative 15. All right, so now on the left-hand side, I'm going to subtract 15 from each side. So I have 5x is equal to negative 15 minus 15 is going to be negative 30. Divide by 5, divide by 5, x is equal to negative 6. Okay, so the first thing we had to do was distribute. Once I've distributed everything, I had to multiply by my power of 10. Once I've done that, I had to simplify on my right-hand side, negative 18 plus 3. Then I could go ahead and start using my properties of equality to move things from right to left and left to right to solve and find that x is equal to negative 6.
Thank you.
You're welcome. Any other questions? Everybody good? The very first one, the answer in here, what I'll do is I'll go ahead and I can write just the answers in so y'all can see them. So x was equal to 105 on the first one. Below that, x was equal to negative 2.4. Over here, x was equal to negative 158. Whoop. There we go. So any of the other ones you would like me to work?
The top one on the right side and the bottom one on the left side.
Okay. So let's see, we'll stop with the bottom left, or stop with the bottom left, start with the bottom left, go away. Okay, again, first thing I've got to do is distribute. That's 7. And then distribute the 2. Okay, so 7 times x will be 7x plus 7 times 0.6 will be 4.2 equals 2 times x is 2x, and 2 times negative 5.6 is going to be negative 11.2 plus 3.4. Before I start combining anything, I want to go ahead and multiply by my power of 10. I only have one decimal place, so that means I need to multiply everything by 10. So 7 times 10 will be 70x plus 4.2 becomes 42. 10 times 2 will be 20x minus 11.2 becomes 112. 3.4 becomes 34. Okay, so now that I've distributed everything, I've used my power of 10 to clear everything, I can see I've got these two terms that need to simplify, negative 112 plus 34. So I have 70x plus 42 equals 20x. Now I've got negative 112 plus 34. I can see that my negative sign is going to be my larger term. And so negative 112 plus 34 will be negative 78. Okay, so check to make sure you've got your calculations correct. I'm going to move my x terms, so I subtract 20x. So I have 50x plus 42 equals negative 78. I have a positive 42 on the left that needs to move. The way I move it is to subtract it. So subtract 42. 50x is equal to, I've got negative 78 minus 42. Remember, I have a negative taking away something, so that means I'm going to end up with a larger negative. And then I add my terms, and so negative 78 minus 42 is going to be negative 120. Divide by 50. Divide by 50. So here you could just go ahead and say x is equal to, and then you can use your calculator to divide 120 by 50, and that would be, since it's a negative divided by a positive, I'm going to have a negative answer, and that will be negative 2.4. Okay, so using this step right here, I could just divide 120 by 50 and get 2.4, and I know it has a negative, so I'd have a negative 2.4. You good with that one?
Yeah.
Okay. So the main thing in working these, if you missed it as we're going through it, look and see where you missed it and why you missed it. Was it just a calculation error? Did you do your steps out of order? What was the problem? What happened for you to miss it? So then this one at the top, all right, so I have room. All righty, so I start by distributing 3, 4. So now I have 3 times 0.06. So that's going to be 0.18x plus 3 times 7 is 21 equals 4 times 0.01 is going to be 0.04x minus 0.31 times 4 is 1.24 plus 0.12. Okay, now I'm looking at my decimal places, and my largest number of decimal places after the decimal is going to be 2 places, so that means I need to multiply everything by 100. Multiply everything on the right, everything on the left. So that means everything, the decimal places will move 2 places, okay? So 0.18 becomes 18x plus 21 is going to become 2100. It is already 21 decimal. So now I have to move my decimal 2 places to the right. So that becomes 2100 equals 0.04x becomes 4x minus 1.24 becomes 124 plus 0.12 is going to become 120. No, it's not. It's going to become 12. Because I moved the decimal 2 places, okay? Now I go ahead and look at it. I've got these terms right here that need to be combined. So I have 18x plus 2100 equals 4x. Now negative 124 plus 12, I know I take the sign of my larger, which is negative, and 124 minus 12 would be 112. Now I'm going to move my 4x by subtracting. And let me erase down here so I can have enough room.
Miss Jennifer?
Uh-huh.
I think I'm kind of cutting out a little bit.
Okay, so yeah, because I see where it says reconnecting. There may be trouble. If you end up dropping out, you can just rejoin. It may be your internet connection. Yeah, because it says reconnecting. Okay, so 18x minus 4x is 14x plus 2100 equals negative 112. Now I'm going to move that 2100. I move it by subtracting. So 14x is equal to, I've got negative 112 minus 2100. So that means I keep my negative sign, add my numbers together, and I'm going to end up with 2,212. Divide by 14, divide by 14. So x is equal to negative 158. Again, I'll get my calculator and divide 2212 divided by 158. Watch for Chad to try to. Let's see if he can reconnect.
Maybe the rain's messing with his Wi-Fi.
Yeah, that's true. It will. You back, Chad?
I think my internet cut out.
Okay. Yeah, it may have trouble going back and forth. Hopefully it'll hang on a little bit. Okay, so the main thing is if you have distributive property, you distribute first. Then you're going to clear your decimals by determining the power of 10 that you need to use based on the number of decimal places you have after, how many places after the decimal. Combine like terms if you need to, and then you use your properties of equality to go ahead and solve for x. Okay? Let's go ahead and, so is that all we had for homework? And then working in the packet, right? Okay. So let's go ahead and move on to lesson 20. Lesson 20, we're dealing with absolute value signs again. Okay. So remember that when we have absolute value signs, that when we talk about absolute value, that talks about distance from zero, but when we have absolute value equations, and especially if we have a variable inside our absolute value sign, there's going to be some things that we do differently here. Okay, so we're going to have some steps that we need to kind of go through to see, and it says algebraic equations that contain an absolute value cannot be solved like normal algebraic equation. Okay, so this tells us that we are going to have some different steps. Because the value inside the absolute value sign may be positive or negative, you must work out the problem twice to allow for each answer. Because remember when we talked about I could have the absolute value of -5 or the absolute value of 5, and they're both going to be 5. Okay, so I could have a negative inside my absolute value sign, or I could have a positive. So because I don't know when I have a variable and I don't know which one it is, I'm going to have to work 2 problems to be able to find those 2 possible solutions. Okay, so it says in most cases there are 2 possible solutions to an algebraic equation with absolute values. It is important that you solve for both solutions. So alrighty, so let's take a look at the sample problem they've given us where we have x plus 3, or the absolute value of x plus 3, plus 5 equals 13. Okay, the first thing you do is to isolate the term in the absolute value sign. That means that anything that is on the same side as the absolute value has to move first. So what I'm going to do is I'm going to put a number 1 right here in the margin. And so I want you to go ahead and make sure that you have highlighted that or underlined it or marked it so you know that that is where you start. Step 1 is to move anything that is with the absolute value, move it to the right-hand side. So if it's a positive on the left, subtract it to move to the right. So that's what they've done here, is now I've got x plus 3 on the left, it is isolated, equals 13 minus 5. 13 minus 5 is 8. So now I have just the absolute value on the left, x plus 3, or the absolute value of x plus 3 equals 8. Now it says because the value inside the absolute value sign may be positive or negative, you must solve for both cases. So this is going to be step number 2, is to solve for both cases. Okay, so you can see that what they did is they said that x plus 3 equals 8, or x plus 3 equals negative 8. So notice what they did is they made what it is equal to, you take it as the positive and the negative. Okay, so that's step 2. Step 3, you're going to solve for each. Okay, so you can see that they said that if x plus 3 equals 8, then x equals 5. If x plus 3 is negative 8, then x would equal negative 11. Now remember, anytime I find a solution and it says x equals something, I can go back to my original equation and plug it in to check. So that's what I'm going to do real quick so you can see why it could be 5 or it could be negative 11. If I have the absolute value of 5 plus 3 plus 5, what I'm doing here is I'm using, we said that x could be 5. That's one of our possible solutions. So I have plugged it in here for x equals 13. So the absolute value of 5 plus 3 is 8. So 8 plus 5 equals 13. So 13 equals 13. That's a true statement because I have something on the left equals something on the right. Okay? Now I'm going to plug it in with that negative 11. Same thing, absolute value of negative 11 plus 3 plus 5 equals 13. So negative 11 plus 3, I would have the absolute value of negative 8 plus 5 equals 13. Well, the absolute value of negative 8 is positive 8. And 8 plus 5 equals 13. So 13 equals 13. Okay? So see, when we plugged in negative 5 and negative 11, I still got true statements. So that's a way you can check. You can just go back and plug in your x values. Okay, so step 1, I'm sorry?
So, like, is there one answer or are there two answers?
There are 2 possible answers. Okay, so with an absolute value, that's why you have to work 2 problems because there's 2 possible answers here.
So, which one's the correct answer?
They both are correct because notice they both gave us true statements when we plugged them in. If I plug in 5 plus 3 is 8, 8 plus 5 is 13. If I plugged in negative 11 plus 3, the absolute value of that is positive 8 as well. So that is why we have to work 2 problems because there are 2 possible answers to this. They are both correct. So if you don't give both answers, then you've missed half the problem, okay? So again, let's go through our steps. Step 1, isolate absolute value. Step 2, after you have isolated, you have to solve for positive and negative solutions. Well, I said solve. Let me say, what's the word? Write equations for positive and negative solutions. And then step 3 is to solve for each. Okay? So I have to isolate my absolute value. I set up an equation, one with a positive solution, one with a negative solution, and then I solve for each. Okay, so let's practice with these. Let's look at our classwork. It says find all possible solutions. So I have 2x plus the absolute value of 2x plus 5 plus 7 equals 18. What did I say step 1 is? I've got to isolate my absolute value. That means that this plus 7 right here has to move. It is positive, so the way I move it is to subtract it. So now I still have the absolute value of 2x plus 5 equals 18 minus 7 is 11. Okay? So that's step 1. I have isolated my absolute value. Step 2 is I am going to set up my 2 possible equations without my absolute value sign. I set up my 2 possible equations, one positive, one negative. So I have 2x plus 5 equals 11. And I have 2x plus 5 equals negative 11. So we isolated absolute value. We've set up our 2 equations. Now we're going to solve each of them. So 2x plus 5 equals 11. The first thing I need to do is subtract 5 from each side. So now I have 2x is equal to 11 minus 5 is 6. Divide by 2, divide by 2, x equals 3. Same thing for my right-hand side. I need to move my 5 by subtracting. So 2x is equal to negative 11 minus 5. Remember, if you need to do negative 11 plus negative 5, then that is going to be negative 16. Divide by 2, divide by 2, x is equal to negative 8. So I have 2 solutions. Any questions about what we did there? Okay, let's look at the next one. The absolute value of 4x minus 3 plus 2 equals 17. Step 1, isolate the absolute value. Go ahead and do that. Isolate the absolute value. I'm going to subtract 2 from each side. So I have the absolute value of 4x minus 3 equals 15. Okay, let's go ahead and write our 2 equations. 4x minus 3 equals 15, and 4x minus 3 equals negative 15. Now I'm going to solve each of them. My negative 3 on the left, since it is negative, I will move it to the right by adding. Add 3 to each side, so 4x is equal to 15 plus 3 is 18. Divide by 4, divide by 4, x equals, now I've got 18 over 4 here, okay? So one of the things that I want to do, I want to either go ahead and leave it as an improper fraction, or, let's see, let me go back. Yeah, I'm just going to leave it as an improper fraction, but the main thing is I've got to reduce that. And since 18 and 4 are both even, I know that they can both be divided by 2. So 18 divided by 2 is 9. 4 divided by 2 is 2. So my first answer is 9/2. I don't have to change it to a mixed number. I can leave it as an improper fraction as long as it is in simplest form. 4x minus 3 equals negative 15. Again, I've got a negative 3 on the left, so I move it to the right by adding. So 4x is equal to negative 15 plus 3. I have opposite signs, so I take the sign of the larger, find the difference of my numbers. So 4x equals negative 12. Divide by 4, divide by 4. X is equal to a negative divided by a positive is a negative, and 12 divided by 4 is 3. So my 2 solutions are 9/2 and negative 3. All right, the last one. The absolute value of 3x plus 1 minus 4 equals x plus 5. I've got variables on both sides, but that does not change what I do here. I'm still going to go step 1, isolate the absolute value. Step 2, set up 2 equations. Well, actually, it is going to change a little bit because in my step 2, when I set up my 2 equations, it's going to look a little different. So I'm going to show you what we'll do. We're not going to start moving things from right to left yet. We still need to set up our positive and negative first, but it's going to look a little different. All right, so the first thing, isolate the absolute value. I've got -4 with it, so I'm going to isolate it by adding 4. So I've got the absolute value of 3x plus 1 equals x. I've got a positive 5 plus 4, so that would be plus 9. Okay? Where I'm setting up my 2 equations. On my first one, if you've noticed that basically I'm writing my equation exactly the same as it is, just minus my absolute value signs. So that's what I do for the first equation is I just drop those absolute value signs and I have 3x plus 1 equals x plus 9. This is considered my positive version of the right-hand side, okay? I'm leaving it exactly like it is. Now, this is where it's going to be a little bit different. And when I write the negative version, I have 3x plus 1 equals, now I'm going to put a minus sign. I'm going to use parentheses and have x plus 9. Okay? So my positive version is leaving it as it is. My negative version, I put a negative sign in front of each of the terms on the right-hand side. Okay? So in just a minute, we'll look at what we do with that negative. I'm going to erase these steps down here so I have room to work. Okay, so on the left-hand side, I'm solving. So I have 3x plus 1 equals x plus 9. Again, I still want my variables to be on the left-hand side, so I'm going to subtract x from each side. So I have 2x plus 1 equals 9. I need my constant to move from the left to the right, so I'm going to subtract 1, so 2x equals 8. Divide by 2, divide by 2, so x equals 4. There's one solution. Now let's look over here to this one where I had to put a negative sign outside of the parentheses, okay? Remember that if I have anything outside of parentheses like this, that means I have to distribute it. And remember, a negative in front of parentheses is the same as a -1, okay? So distributing a negative is the same as distributing a -1. So -1 times x, I'm going to go ahead and write 3x plus 1 equals, a negative times x is -x. A -1 times a positive 9 makes it a -9. So basically, if you have a negative sign in front of the parentheses, that means you have to take the opposite of everything inside the parentheses. So my positive x becomes -x. My positive 9 becomes a -9. Does everybody follow me on that? If there's a negative sign outside parentheses, when I distribute that, that means everything inside parentheses has opposite signs. So now I can start solving by moving things from left to right using my properties of equality. I want to move my variables to the left. On the right-hand side right now, it's negative, so I move it by adding. So 3x plus x is 4x plus 1 equals -9. My 1 on the left is positive, so I move it by subtracting. So 4x equals -9 minus 1 is the same as -9 plus a -1, so that will be -10. Divide by 4, divide by 4. Again, I can see that I'm going to end up with an improper fraction, but I want it to be in simplest form. So I've got to simplify 10 over 4, or -10 over 4. They're both divisible by 2. So I end up with -5 over 2. So my 2 possible solutions here are 4 and -5/2. questions about that?
I do. How come when you added the 1, you added the 1 to the 3x, they're not like terms. How did that work?
I didn't add 1. I did not add 1 right here. I added this x.
Oh.
Yeah, so I added x to each side. And so 3x plus x is 4x. I
Okay.
still had that plus 1 over here, and I had to move it by subtracting.
Okay.
Okay. Any other questions about what I did? The main thing to remember is just like we did in these problems up here in the beginning, when I had a positive 15 and a negative 15, if I have more than one term on the right-hand side, my positive version is just like it is. My negative version, I have to do a negative sign, then put in parentheses what is my positive version on the original. Okay? So let's go ahead and practice a few of these. Let's go ahead and do activities 2. Go ahead and work the first one in activities 2, and then we're going to go through it together. Step 1, isolate. Step 2, write equations, one positive, one negative. Step 3 is solve. Okay, y'all about ready to look at these? Look at this one. Okay, step 1, isolate my absolute value. So that means I'm going to subtract 6 from each side. Absolute value of 3x plus 3 is equal to 21 minus 6 is going to be, what is 21 minus 6? I've lost my train of thought. What is that?
15.
15. Good grief. Okay, so now I know that I'm going to have to set it equal to positive 15 and negative 15. So I drop my absolute value signs. 3x plus 3 equals 15, and 3x plus 3 equals negative 15. Okay, so now I'm going to solve. I solve by subtracting 3 from each side. So I have 3x is equal to 15 minus 3 is 12. Divide by 3, divide by 3. So x equals 4 on my positive side. Negative side, subtract 3, subtract 3. 3x is equal to negative 15 minus 3 is going to be negative 18. Divide by 3, and x equals negative 6. How'd you do? Did you do okay? Do you remember each step? Do all your calculations correct? Good deal. Let's do the one underneath it. Go ahead and work the absolute value of 6x minus 5 plus 4 equals 27. Go ahead and work that one. I'll mute y'all real quick. There's a delivery guy out front. Hang on. So you won't hear my dog bark. All righty, let's get ready and check this one. Okay, we had to isolate the absolute value. To do that, it has a positive 4 with it, so to move it, I have to subtract 4. Oh, let me check our time. Let's go ahead and take a 5-minute break, then we'll come back and check these. All right, take a break. All righty, we'll get ready and come back and check this problem. Give everybody a chance to get back. Okay, so on this one, like I said, step one, we've got to isolate our absolute value first. Right now, it has a positive 4 with it, so I've got to take away 4 from each side. And I have the absolute value of 6x minus 5 equals 27 minus 4 is 23. Now I've got to set up my two equations, one with a positive 23, one with a negative 23. So I have 6x minus 5 equals 23, and 6x minus 5 equals negative 23. And then I go ahead and solve each of them. I have a negative 5 on the left-hand side, so I move it by adding. Add 5, add 5. So 6x is equal to 28. Divide by 6, divide by 6. X is equal to, I had 28 over 6. I have an improper fraction. 6 will not divide into 28 evenly, so I go ahead and reduce. 28 divided by 2, 6 divided by 2. So I end up with 14 over 3 is my positive solution. Look at my negative. Again, I have a negative 5 on the other side, on the left-hand side, so I add it. Add 5, add 5. 6x.
Wait,
I'm
can
sorry.
you go back? Can you go back to that problem? How do you get 14 over 3?
Okay, 28 divided by 2 is 14, and 6 divided by 2 is 3. So I just simplified my fraction. I put it in reduced form.
Oh, I didn't do that. I just left it as 28 over.
Yeah, so you always want to check anytime you have a fraction as an answer, you always want to make sure it's in simplest form. So always look and see if you can reduce it. All righty, so then we went ahead and added 5 on each side. So I have 6x equals, I've got negative 23 plus 5. I take the sign of the larger, which is that negative. Now I've got to combine them by finding the difference. So I'm going to have negative 18. Divide by 6, divide by 6. I have a negative divided by a positive, so I have a negative 3. So my possible solutions are x equals 14 over 3 or x equals negative 3. Everybody feeling a little more comfortable with it? Let's go ahead and look on the right-hand side. Go ahead and work both of these. All right, when you finish yours, take a look at the screen and you can check yours. Look and see if you got the right answers. If you missed it, I want you to look through the steps and see where you missed it. So with the absolute value of 5x minus 11 minus 17 equals 32, your two possible answers are x equals 12 and x equals negative 38 over 5. That's just left it as an improper fraction. There's nothing I can do to simplify it. Then the next one, the absolute value of 7x minus 40 minus 42 equals negative 19. I have x equals 9 and x equals 17 over 7. Any questions about either of those problems? All righty. So now what we're going to do is we're going to go ahead and move on to lesson 21. All right, lesson 21 is solving algebraic equations multi-steps. Okay, so now you can see that in these problems, I've got fractions and I have decimals. We have a certain order to follow to eliminate these, okay? So remember earlier we eliminated fractions, then we eliminated decimals, now we've got to do both. So let's go ahead and take a look. It says when solving algebraic equations with multiple steps following the order of operations does not always work because of the variables. Follow these steps to make the process simpler. Step 1, eliminate fractions. So if it has fractions in it, that's where you always start in an equation. Step 2, eliminate decimals. That's where we look at our powers of 10 to determine what we need to multiply by to be able to clear the decimals. Simplify each side of the equal sign. So if I have like terms that need to be combined on one side or the other, that's where I combine like terms. Then I isolate the variable using the properties of equality. That's usually where I have my variable on the left. And then I want to solve for the variable using our properties of equality. So fractions, then decimals, any simplifying that needs to take place, isolate the variable, solve for the variable. Okay, so those are our 5 steps that we need to follow when we are solving these. So let's go ahead and look at the example they've given us. We have 3x plus 1/4 equals 2.95. So step 1 is to eliminate the fraction. Remember that when I am getting rid of the fraction, that means I have to multiply by the common denominator. Fortunately, I only have one denominator here, so I don't have to really think too hard. I see that it's a 4, so that means I have to multiply both sides by 4. I multiply 4 times 3x and 4 times 1/4, but then I also have to multiply 4 times 2.95. 4 times 3x is 12x. When I multiply 4 times 1/4, remember that would be 4 over 1 times 1 over 4. That would be 4 over 4, which cancels to be 1. So again, when I cancel those 4s, what's left is the numerator. Okay, so that is 1, and 2.95 times 4 is 11.8. So we've cleared the fraction. That was step 1. Step 2, now we have to clear the decimals. I see that I have got one decimal place, so that means I have to multiply everything by 10. Okay, so 10 times 12x is 120x. 10 times 1 is 10. 10 times 11.8 is 118. Now I have no fractions, I have no decimals, and I can just start using my properties of equality to solve. So then I'm going to subtract each side. I'm going to subtract 10 from each side. And I end up with 120x equals 108. Then I have to divide by 120, divide by 120. And so I grab my calculator and I divide 108 by 120, and I find that x is equal to 0.9, 0.9. Okay, and the directions say answers may be expressed as proper or improper fractions or as decimals. Because my problems have decimals and fractions in them, I'm not limited to whether I have a fraction answer or a decimal answer. I can do either or. The main thing is if I use a fraction, it has to be in simplest form. It can be an improper fraction in simplest form. Okay, so let's practice with these, using these steps 1 through 5. Looking at our classwork 1, I have a fraction and a decimal. My first step is to clear my fraction. I clear my fraction by multiplying by the denominator. The denominator is 3. So I multiply my entire equation by 3. 3 times 1/3 x, 3 times -2, and 3 times 0.6. 3 times 1/3 x, again, my 3's are going to cancel, and all that I'm left with is 1. So I've got 1x, or just x, minus 3 times -2 is going to be -6. So on the left-hand side, I have x minus 6 equals 3 times 0.6 is going to be 1.8. So I've cleared my fractions, or my fraction. Now I've got to clear my decimal. I have 1.8, so I have one place after the decimal, so that means I multiply everything by 10. 10 times x is 10x. 10 times -6 is -60, so I have 10x minus 60 on the left-hand side, and 10 times 1.8 is 18. Now I've eliminated my decimals, so I can start using my rules of equality to solve for x. Add 60 to each side, and 10x is equal to 18 plus 60 is 78. Divide by 10, divide by 10. And again, I could decide, do I want to divide 78 by 10 and get a decimal answer, or do I want to do it as a fraction? If you decided to leave it as a fraction, then you would have x is equal to, now remember, I've got to go simplest form, so 78 divided by 2, 10 divided by 2. 78 divided by 2 is going to be what, 36? Nope, that's 72. 38. Nope, 39. 78. So that'll be 39 over 5. Or if I wanted to do in decimal form, 78 divided by 10 is going to be 7.8. So I could either leave it as a fraction in simplest form, or I can do a decimal, which would be 7.8. It would be up to you. Any questions on that, how we did anything? All right, let's look at the next one. I've got 4x plus 1/3 equals 1.95. I've got to multiply both sides by 3 to clear that denominator. So I have 3 times 4x is 12x. 3 times 1/3, my 3's will cancel and I'm left with just 1. So 12x plus 1 equals 3 times 1.95 is going to be 5.85. Again, use your calculator. We're in Algebra 1, so we can do that now. Okay, so now I start simplify, or I've got to clear my decimals. I've got 2 decimal places, so I know that I have to multiply by 100. All right, but now when I multiply 100 by 12, I get 1200x plus 1 times 100 is 100. 100 times 5.85 will be 585. I need to start solving for x, so I move my positive 100 from the left to the right by subtracting.
Wait, I have a question. How come you kept the 1 instead of just multiply by 3?
Okay, so if I multiply, when I multiply 3 times 1/3, that's the same as 3 over 1, right?
Mm-hmm.
So 3 times 1 is 3, and 1 times 3 is 3, so I end up with 3 over 3.
Oh,
3 divided by 3 is 1. Okay, so that's just a simpler way. When I did that, basically I just canceled my 3's, and I'm left with 1.
that makes sense.
All righty, but I'm glad you're asking questions. Okay, so we have 1200x plus 100 equals 585. So we're subtracting 100 from each side. So we have 1200x is equal to 485. Divide by 1200, divide by 1200. We've got some really big numbers. So again, I can leave it as a fraction in simplest form. So that would mean, let's see, I'm going to have to divide, let's see. Both of them I can divide by 5. And 485 divided by 5 is going to give me 97. 1200 divided by 5 gives me 240. So I could either leave it as 97 over 240, or I could divide 485 divided by 1200, and I end up getting a decimal that I would have to round. Okay, so it's got 0.4041, and if you use your calculator, you can see that that 6 is repeating. Okay, so you could either leave it as a fraction in simplest form, or you could do the decimal. Now, one of the things to always note is that if you leave your answer as a decimal, you always want to look to see, did the directions tell you what place value to round to? It didn't tell me that, so I just went ahead and wrote the complete answer with my repeating 6. Okay, if it would have said round to your nearest 10, round to your nearest 100, then I would have done that, but it didn't say, so I just went ahead and wrote it. Okay, let's do a couple more as practice. Together, we'll do the the left hand together, and then you'll do the right hand on your own. So my first step, clear fractions. I need to clear my 5. Clear my 5. So 5 times 1/5 x, 5 times -3, 5 times 1.2. 5 times 1/5 x, we know that 5 times 1 is 5, and 1 times 5 is 5. So 5 over 5, again, is 1. Those 5's cancel, left with 1. So I've got 1x minus 5 times -3 is -15. So 1x minus 15 equals 5 times 1.2. 5 times 1.2 is going to be 6. Now I've got 1x, or just x, minus 15 equals 6. So I've got to add 15 to each side. And that one was easy enough. I end up with x is equal to 21. All right, the one below that, my denominator is a 4, so I have to multiply everything by 4, multiply my fraction, multiply my -5, multiply my decimal 2. Again, when I multiply 4 over 1 times 3 over 4, that's going to give me 12 over 4, which equals 3. Notice that what I'm left with is what is in the numerator. When those 4's cancel, I'm left with the number that's in the numerator. So as we keep going through these, that's kind of a shortcut thing that once you understand why it's 3, you can see that by clearing the denominator, I'm left with just the numerator. Okay, so you're left with 3x, and then 4 times -5 is -20, so 3x minus 20 equals 0.8. I've got to clear my decimals. I've got one place after the decimal, so I have to multiply everything by 10. 10 times 3x, 10 times -20, and 10 times 0.8. 10 times 3x, 30x, minus 10 times 20 is 200, equals 10 times 0.8 is 8. So now I've got why did I do okay, I don't know. Anyway, I've got to add 200, add 200. 30x is equal to 208. Divide by 30, divide by 30. I can go ahead and leave it as a fraction in simplest form. So 208 divided by 2, 30 divided by 2. 208 divided by 2 will be 104 over 30 divided by 2 is 15. Whoop. Or I can write it as a decimal, and 104 divided by 15 gives me another repeating decimal, so 6.93, but just my 3 is repeating. So I can write it as a reduced fraction, reduced improper fraction, or a repeating decimal. All right, now I want you to work on the right-hand side. Now look at this, look at the very last one. Notice I have 2 denominators. I'm going to have to find a common denominator to multiply everything by. Okay, I've got a 3 and a 4. Hint, hint, you will need to multiply them together. Go ahead and work on those. All righty, we'll get ready to start going through these. So the first one, my denominator is 7. I know that I need to clear my fraction first by multiplying everything by 7. 7 times 1/7 x, 7 times 2, 7 times 4.8. So 7 times 1/7 x is going to leave me with 1x, or just x. 7 times 2 is 14. 7 times 4.8 is going to give me, multiply that out, 7 times 4.8, oh, not 0.8, is 33.6. So I've cleared my fractions. Next step, decimals. I have one decimal place, so that means I need to multiply everything by 10. So 10 times 1x, or 10 times x, is 10x. 10 times 14 is going to be 140. And 10 times 33.6 will be 336. So now I've cleared my decimals. Next step is to start solving by using my properties of equality. I have 140 on the left-hand side that needs to move, so I will subtract 140 from each side. So 10x is equal to, I've got 336 minus 140 is going to be 196. Divide by 10, divide by 10. X is equal to, if I wanted to go ahead and say 196 divided by 2, that's going to give me 98 over, and 10 divided by 2 is 5. So I can leave it as x equals 98 over 5, or I could go ahead and divide 196 divided by 10, and that's going to be easy because I know that when I divide 196 by 10, that just means I move my decimal place one place to the left. So I've got 19.6. So I could leave it as a fraction or put it as a decimal. Any questions about that? How did everybody do? You feeling okay about it? Then our next one, of course, the way they always do is they start off pretty easy and then they make it a little bit harder. So they decided to throw in 2 denominators here. And I told y'all my little hint was that you would multiply your denominators together to get your common denominator. So let me change colors real quick and we'll make that yellow so I can see it better. So I'm going to multiply everything by 12 because 3 times 4 is 12. So now when I multiply, I'm going to have 12 over 1 times 2 over 3. Okay, that's what we're going to be doing here. And 12 times 2 is 24. So 24 divided by 3, I'm going to end up with 8x. Okay, 12 times 2 is 24. 1 times 3 is 3. 24 divided by 3 is 8. Plus 12 over 1 times 3 over 4. 12 times 3 is 36 over 4 is going to be 9. So 8x plus 9. Now remember, there's something that we can do that when we are multiplying, we can cancel before we multiply. That way I don't end up with such big numbers. So if I wanted to do that, then I can look at what is in the numerator that would cancel with something in the denominator. And I can see here I've got a 12 and a 3. So 3 divided by 3 is 1. 12 divided by 3 is 4. So then 4 times 2 is 8, and 1 times 1 is 1, so that would get me to 8 faster. Or if I wanted to cancel 12 over 1 times 3 over 4, I've got a 12 and a 4. 4 divided by 4 is 1. 12 divided by 4 is 3, so 3 times 3 is 9. If you're not comfortable with canceling before you multiply, don't worry about it. Just go about it like you usually do, multiply and then divide to simplify. So you would have ended up with 8x plus 9 is equal to, and I've got to multiply 12 times 1.44. So 1.44 times 12 is 17.28. I've got 2 decimal places here, so that means I need to multiply by 100. Multiply by 100. 100 times 8x is 800x. 100 times 9 is 900. 100 times 17.28 is 1,728. I can start solving for x now. The first thing I need to do is subtract 900 from each side. So 800x is equal to 1728 minus 900 is going to be 828. Divide by 800, divide by 800. X is equal to, okay, so if I wanted to go ahead and leave it as a leave it as a decimal, 828 divided by 800. Ooh, I definitely didn't do that right. 828 divided by 800 is going to be 1.035, or if I wanted to do the reduced fraction, 828 divided by 800. Remember, I don't know if you remember or not, but if you do remember, rules of divisibility, to do about a 4, I look at the last 2 digits, or if it ends at 00, I know it's divisible by 4. If I don't remember those rules of divisibility, I can just always start with my smallest number and say, hey, they're both even numbers. So 828 divided by 2 and 800 divided by 2. So 828 divided by 2 would be 414 over 800 divided by 2 would be 400. Again, I can divide by 2, divide by 2. 414 divided by 2 is going to be 207. 400 divided by 2 is going to be 200. Now I can look at these and think about my rules of divisibility. Now I've got 207 and over 200. If you remember the rules of divisibility, again, I can check and see, I know 207 is not even. So I can go ahead and look at that. I can try 3. 7 plus 2 is 9. That would be divisible by 3, but 200 is not divisible by 3. My last 2 digits are 7, and I do have 00, but 7 is not divisible by 4, so I know that's not going to work. 6 doesn't work because it has to be divisible by both 2 and 3. 9 would work for the numerator, but not the denominator, so this is my fraction in simplest form. To me, it's easier just to whip out the calculator and use the decimal form. Questions about what we did?
Not about what we did, but like if this was on a test, which would you want as an answer?
Whichever one. I would count either one. So whatever one you're more comfortable with. Okay? If you're not as comfortable with reducing fractions and you're not sure you would reduce far enough, use your calculator and just divide. Okay? So you could just start right here and divide 828 divided by 800 and get 1.035. Okay? So it's whatever you're most comfortable with. Any questions about the steps? Again, it's something that you're just going to need to think through as you're doing your homework. If you get stuck, look back. Look back at those steps. Hopefully you either circled that in your textbook, you know, if you want to put a big circle around that section so you know that's where you need to look. If you underlined, highlighted, did something, put a star by it, whatever you need to do to help you remember that this is where you need to look if you get stuck. Follow these steps, okay? So we're going to talk about homework for a minute. It is 11:54, so we've got just a few more minutes left. Let's back up to lesson 20 real quick, where we were. Let's see, lesson 20. Our absolute value work. Let's go ahead and look on page 44. And we're going to do activities 3 and activities 4. Notice activities 4 is a good bit of kind of review here. Here we are multiplying variables. Remember, when we multiply with variables, we add the exponents. Remember, if your book is printed with this funky little check marky, almost like a square root symbol, that means to divide. Okay, so if you need to change those to division signs so you won't forget. And remember that when you divide using exponents, you subtract them.
Is this page 44?
Yes. So in this section, we are multiplying numbers with variables with exponents. We are dividing numbers with variables and exponents. If you don't remember, look back to those lessons. Then the next thing, we're working with the distributive property, where we have to distribute the number outside parentheses to the number inside parentheses, and then we work on solving. And then lastly, we have one problem where we clear fractions. Oh, look how nice they are. They have 7 and 14 and 28. 14, good grief. 7, 4, and 28. 7 times 4 is 28, so you know that's going to be your number to clear the denominators. And then over here, we clear using decimals. Okay, so we've got kind of a mixed review here in activities 4. Then we will move on to, let me flip back to lesson 21. And we will go to page 48. Page 48, we have our absolute value. And then we have our multi-step. Actually, no, it's not multi-step. It's just either decimals or fractions. One of the things I want to tell you real quick is notice here, they said identify any extraneous solutions for our absolute value. So one of the things that I kind of get frustrated about with this book is they'll say, hey, you know, do this, but then you go, well, you didn't even tell us what that means, okay? What an extraneous solution means, what I want you to do is make a note right here that says, check answers by plugging in values of X. Okay, you need to check your answers. Now, if you do not end up with, you know how we said it would be something equals something and it makes a true statement? So if you end up with something equals something and it's not a true statement, it is extraneous, which means it is not a solution. That's what extraneous means, is that it's not a solution. Okay, so that means you're going to work the problem. Then when you get your answer, you plug it back in like I did. Where did I do that? Let's see, that was absolute values. Let me flip back. I'll go ahead and leave this here for a minute for y'all to read. Check your answers by plugging in the values of X that you're able to solve for. If you do not end up with something equals something and it makes a true statement, it's extraneous, and it's extraneous means it's not a solution. So real quick, let me flip back over to lesson 20. Okay. So remember here, when we ended up with on activities 2, we said X equals 4 and X equals -6. So that is where I would go ahead and I would say 3 times 4 plus 3 plus 6 equals 21. 3 times 4 is 12. 12 plus 3 is 15. The absolute value of 15 is 15 plus 6 equals 21. 21 equals 21. Check. That is a true statement. It is a solution. Let's pretend, okay? We're going to pretend for a minute. We're going to pretend that here we ended up with x equals -5, okay? Remember, this is just pretend. Our answer was -6, but we're pretending. So absolute value of 3 times -5 plus 3 plus 6 equals 21. So here I would have 3 times -5 is -15. -15 plus 3 would give me -12. The absolute value of -12 would be +12. So then I'd have 12 plus 6 equals 21. 12 plus 6 is 18. 18 does not equal 21. So this is what we would call an extraneous solution, because this does not equal that. So if I don't have a true equality, that's what's called an extraneous solution. The only time you can find extraneous solutions is by plugging in your answers, okay? So that's what you're going to need to do for that homework, where it says identify extraneous solutions. That means you have to plug in your answers. If you do not end up with a true statement where something equals something and it is true, if it's false, it is extraneous. Okay, so you could either identify it with the does not equal sign, or you can write extraneous.
So if you get an extraneous answer, you're wrong, basically.
Well, it doesn't mean you're wrong. It means that that is not an answer for that absolute value problem. Okay, so plug it in. If it doesn't equal something, it's extraneous. So our homework, let's go through that real quick. I'm going to write it on our sheet. So our homework for absolute value.
What would you do with it then?
You just write that it's an extraneous solution, because it works through the problem. It may work through the problem, but when you plug it in, it does not make a true statement. So that means that answer only has one solution. For the ones that both of them are true, they have two possible solutions. But sometimes they can only have one real solution. And the only way you can figure it out is if you plug in your answers. Okay? So basically what you're doing is you're testing your answers to see, does this problem have one solution or does it have two solutions? Does that make sense?
No.
Plug in your answers to test if it has one solution or two solutions. On all the ones that we did earlier, we found that we had two solutions. Okay, but we're going to plug in and see which ones have one solution and which ones have two solutions. So for our homework, let's see, lesson 20, we said we have, that's page 44, activities 3 and 4. And then for lesson 21, this is going to be page 48. We're going to have activities 3 and 4. The only ones that you have to check for extraneous solutions are those ones with absolute value, because remember we talked about with absolute value, it could be a positive or it could be a negative. We don't know, so we have to test for both answers. When we get our answers, we plug them back in to test them to see if they make true statements. If they're both true, then there's two answers for that problem. If only one is true and the other's extraneous, then that means there's only one real answer for that problem. Okay? So that's what you'll need to do only for the absolute value questions. All right. So page 44, activities 3 and 4. Page 48, activities 3 and 4. What we're going to be doing is on Monday when we meet back in class, we'll be checking this homework. Then we're going to be working in our packets on Monday. So make sure you have your packets that we did with our fractions and decimals and multi-step. And so we're going to be working in those on Monday in class. So please make sure you
So
bring
you
them.
want us to finish it this week and then bring them to Monday, or do you want us to bring them to class?
Bring them to class Monday. You have no assignments right now in your packet due Monday, okay? So just do pages 44 and 48, but bring your packet to class Monday because we're going to work on those in class, okay? Because what we're going to end up doing is instead of giving you a test on this material, we're going to use our packet, and I'm going to give you a grade on your packet, but you'll also have some bonus from the packet, but I'm going to count the packet as a test grade. But we're going to work on it in class so we can work on it together. You can ask questions if you need to, that kind of stuff, okay? All right. If you have questions as you're working through these, let me know and I'll be happy to help you. If you have questions and need to stick around after everybody else signs out, that's fine. You can hang on and ask questions. If you are good to go, have a great weekend and I will see y'all Monday. All right. Do you guys have questions?
I'm still kind of having trouble with on lesson 20, like in the classwork, the third question, the one, the 3x plus 1 minus 4 equals x plus 5. I'm kind of having trouble with like those kind of problems with the after the absolute value part.
Okay, so you're talking about in activities 2, or where are you?
I'm talking about in classwork 1.
Classwork 1, okay. So the very last one?
Yes.
Okay, I'm gonna go ahead and erase all my work for that one and we're gonna work through it again.
Miss Jennifer?
Yes.
I had a question about the homework we had from Monday. It
Okay.
was the last one, 3 times 0.3x plus 0.5 equals 2 times 0.2x minus 0.9 plus 0.3. So I didn't hear the answer for that one.
So let's see.
I got -6. I just didn't know if that was correct or not.
So this was on, which problem was it?
This was on the right side, the bottom one.
Yes, x is -6.
Okay, I didn't hear you say it earlier, so I was like, did I get it right or did I get it wrong?
Yes.
Okay, all right,
X
thank you,
is
Miss Jennifer.
-6. You're welcome. All right, let's see, Chad, let's go ahead and work through this. Okay, first of all, what is my first step? Tell me I need to do.
Get rid of the 4.
Okay, I need to get rid of the 4. How am I going to do that?
Add it to
Add it.
5.
Okay, so add 4, add 4. So now I am left with the absolute value of 3x plus 1 equals x plus 5. You good with that so far? Okay, now my next step is I've got to write my 2 problems. So basically, when I'm writing my first one, which is what we call, like I said, the positive one, basically all I'm doing is I'm rewriting the problem and not using, and I'm eliminating those absolute value signs.
I don't think screen share is on.
Oh, okay, let me get it back, sorry. There we go. All righty. Okay, so we added 4 to each side. Oop, and I forgot to add my 4. Okay, so we have 3x, the absolute value of 3x plus 1 equals x plus 9. And I said when I write my first one, 3x plus 1 equals x plus 9, basically I'm just rewriting what I've got right here and eliminating the absolute value symbols. Okay, so I'm just basically writing exactly what this is without the absolute value symbols. Okay, so we got the first one, but I have to do the negative of that as well. So that means I have to take the negative of my right-hand side. So when I write it, it's going to be 3x plus 1 equals, I'm going to put my minus sign, and now I'm going to put x plus 9 in parentheses.
How come we have to put it in parentheses?
Because I can't, if I just had minus x plus 9, then this is just a negative x, and I haven't changed the sign of that plus 9. Remember, if my negative is outside, I have to change the sign of x, and I have to change the sign of 9. So if I didn't put them in parentheses, I wouldn't necessarily remember to change those signs.
Oh.
Okay, so now we'll go back over to the right and to the left-hand side, and we'll solve this one. So I need to subtract x from each side, so my x's are on the left-hand side. So 3x minus x is 2x, so I have 2x plus 1 equals 9. You good with that so far? Okay,
Oh,
now what am I going to do?
Subtract 1 from 9, that makes it 8.
Good.
8 over 2 is 4.
Good.
X equals 4.
Okay, there's my first one. Now let's go back over here to my negative one. I've got 3x plus 1 equals, now I've got to distribute that negative, and like I said, having a negative there is like having a negative 1. So that means I have to distribute negative 1, so that means I have to multiply everything by negative 1. So negative 1 times positive x is negative x. Negative 1 times positive 9 is negative 9. You good with that so far?
Yes.
Okay, now what am I going to do?
Now you got to add a negative x to 3x.
Good, so I'm going to add x to each side. So now I have 4x plus 1 equals negative 9. And then what?
Then you got to subtract 1 from negative 9.
Good, so 4x is equal to?
It's negative 10.
Negative 10, good. Next step?
Divided by 4.
Divide both by 4. So now I have x is equal to negative 10/4, but I can reduce that.
Is it negative 5 over 2?
Negative 5 over 2, exactly.
Okay, that makes sense.
Okay, and so then, like I said, when I'm doing extraneous solutions, basically I take my answer, I would take 4, plug it back into my equation to make sure it made a true statement, and then I would take negative 5/2 and plug it back in. Do you want to work through that, or are you good with that?
Yeah, I'm good with it.
Okay.
I did have one more question.
Sure.
It's another lesson because last week.
Yes, that's what I was going to ask you, if there was anything that you needed help on from last week when you were out.
Yes, ma'am. This lesson 18.
Okay.
That was kind of hard. Me and my mom went over it, but I still kind of don't understand it.
Okay, so what we're doing here is to be able to clear fractions, to be able to get a fraction out of my problem, I have got to multiply my entire equation by a number that will, if it's just one fraction, then I only have to multiply by that denominator. But if I have more than one number, I have to find a common denominator. Okay, so think about like when you're adding or subtracting fractions and you have to have common denominators. It's the same thing here, except for I have to have a common denominator. I've got to have a common number to multiply everything by to get rid of that denominator. So let's go ahead and work through. What I'm going to do is I'm going to erase this, and let's go ahead and work through. We'll look at the classwork here. Whoop. Do I have my eraser? Why isn't it erasing? Okay, so if we look at this classwork, and I have a 4 and a 2. Whenever I'm trying to find a denominator to eliminate, I want to look and see, hey, is one of these numbers one that I could possibly use? So what I have to ask myself is 4 divisible by 4? yeah, is 2 divisible, will 2 divide into 4? So I'm trying to see, can I divide 4 into 4 and 2 into 4? And that works. So I know that my common denominator is 4. So that means I can multiply my entire problem by 4 to get rid of those denominators. Okay? So what I'm going to do is I'm going to write it step by step. But remember, whatever's outside parentheses, I have to distribute to everything inside parentheses. Okay? So what I'm going to do is this would be the same as multiplying 4 times x over 4 plus 4 times 3x plus 1 over 2 equals 4 times 16, which is 64. Okay? So now, when I've got 4x over 4, because remember, if I have 4 times x over 4, that's going to be 4 over 1 times x over 4. So 4 times x is 4x, and 1 times 4 is 4. Are you good with multiplying fractions? Are you comfortable with that?
Yes.
Numerator by numerator, denominator by denominator. If it's a whole number, I understand it has a denominator of 1. So when I multiplied 4 over 1 times x over 4, I ended with 4x over 4. So now what I can do is I can go ahead and cancel these. I can simplify. Okay? So if I'm right here with 4x over 4, what in the numerator will cancel with my denominator?
4.
4. So I'll change my color real quick so it won't be all the same color. So I can see that 4 and 4 are going to cancel because 4 divided by 4 would be 1, right? So what is all that I have left?
X.
X. Okay, so I'm going to bring my x down. Plus, I'm going to do the same thing in the next part. I've got 4 times 3x plus 1 over 2. What in my numerator will cancel with my denominator?
2 and 4.
Okay, so 2 divided by 2 is 1. 4 divided by 2 is 2. So since I still have that 2 outside of parentheses, then I've got to distribute it to 3x plus 1.
Wait, how come the 3 right there? Oh, wait. How come you put a 4 right there? How come you put a 4 right there?
Okay, because my 4 was outside here. And remember with the distributive property, let me change my color real quick. My 4 was out here. And remember with the distributive property, I have to multiply by everything inside parentheses. So I have to multiply 4 by 3x plus 1. Okay?
So,
now I'm going to show you this real quick and what you could do if it helps you to see it better.
So basically, if I ever have a thing like that, like it's maybe like 2x minus 3, if I have to multiply, I always put the number that I'm multiplying before that.
Yes, I've got to put it just like we did with that negative sign a minute ago. When I have more than one term, I have to put it in parentheses so I know I've got to distribute that number because I've got to multiply 4 by 3x and 4 by 1.
Oh.
Okay? So in this situation, though, we've canceled before we multiply. So let's go ahead. So then I would distribute 2 times 3x is going to be 6x. And 2 times 1 will be 2. Okay, but what I'm going to do real quick is I'm going to show you, had we not canceled right there, I'm just doing this part right here, okay? We had 4 times 3x plus 1 over 4. That's what we originally had. But we decided not over 4, over 2. Okay, that's what we had on that right-hand side. but then we said, hey, we can cancel first. Had we not canceled, I would end up with 4 times 3x and 4 times 1. What is 4 times 3x?
12x.
12x. And then 4, so I would have 12x plus, what's 4 times 1?
Oh, 4.
4 over 2. Okay, so had we distributed first, I would end up with 12x plus 4 over 2. In this situation, this means I have 12x over 2 plus 4 over 2. Okay, so had I not canceled in this step right here, when we canceled first, I would end up with 12x over 2 plus 4 over 2. What is 12x divided by 2?
6x.
6x. What is 4 divided by 2?
2.
So I'd end up with 6x plus 2, right?
Mhm.
That's what we got over
So
here.
canceling just kind of saves time.
Yes, it saves time, it saves work. Okay, so if you go ahead and cancel when the number is outside parentheses, if you can, it's just going to make it less work. Okay, you're still going to get the same answer, but it's less work. So now we have x plus 6x plus 2 equals 64. Now I have x plus 6x. Those are like terms, so I can combine those. What is x plus 6x?
7x.
7x. So I have 7x plus 2 equals 64.
I subtract 2 from both sides.
Yep, subtract 2, subtract 2. So 7x is equal to 62. Divide by 7, divide by 7. This was a fraction problem, so we can leave our answer as an improper fraction in simplest form.
Okay. That's easy. That was pretty easy.
Does that help? And then like this next one, I have denominators of x, x squared, and x. So if I have variables, I find the variable with the largest exponent to be what I multiply everything by. Okay, so when this one, I have to multiply everything by x squared. So again, I have to distribute that x squared to each term. So for the first one, I would have 6x squared over x plus 5x squared over x squared equals x squared over x. And now I start simplifying. Are you good with how I ended up with 6x squared over x plus 5x squared over x squared equals x squared over x?
Wait, how come you change the 1 to an x squared? Oh, because x squared times 1 equals x squared.
There you go. So now I can start simplifying. Now, I'm doing x squared divided by x. Think about when we were doing, what do I do with their exponents? Bless you. When I divide variables with exponents, what do I do? I subtract the exponents. So remember,
Right.
an x by itself is the same as x to the first power. So this would be x to the second power minus 1. So I would have x to the first is what's left, right?
So I just cancel out the 2, the exponent.
Yes. So this x cancels, this 2 just becomes a 1. So I still have an x left there. So then that means there I have got 6x plus, what happens with my x squared over x squared?
Becomes x.
Uh-uh.
Or it goes away.
X squared divided by X squared is 1, so they just cancel out because then 5 times 1 is just 5. Excuse me.
Wait, shouldn't, oh, never mind.
Are you good?
I was just thinking, I forgot, I was wondering why X squared was on the bottom, but I remember that 5 was over X squared in the beginning.
Yeah.
So
There you go. Good job. Okay, so we just end up with a 5 there because our X squared over X squared cancels, equals. Now, just like we had in the beginning with 6x squared over X, we just have X squared over X. So what happens there?
it turns, you take away the X in the
My X cancels there, and that X my 2 becomes the first power, so I just have an X. So now I have 6x plus 5 equals X. Are you good with that?
Yes.
Okay, now we start combining, or we move things using our properties of equality. I want my variables to be on the left-hand side, so I'm going to subtract X from each side. 6x minus X is 5x plus 5. And now on the right-hand side of my equal sign, since I did X minus X, that's just 0. Okay, but then I move my 5 by subtracting it, and I have 5x is equal to negative 5. Divide by 5, and X is equal to negative 1.
But how did that 6 become a 5x?
Because I did 6x minus X when I moved my X from the right-hand side to the left-hand side. To move it, I had to subtract it. So remember, that's the same as 1x. So 6x minus 1x, 6 minus 1 is 5.
So wait. Oh yeah, because we wanted to get all the X's on one side and all the
Yeah, we
numbers
want to
on the other.
move the variables to the left-hand side, so that's why I had to move it from the right of the equal sign.
That makes
Good. Does that help, or do we need to do any more?
Yes, and that really helps. Thank you.
You are so welcome. If you need any more help, just let me know, and we can set up a Zoom to work together if we need to. Or like I said, on Monday, we're going to be working on our packet in class. And so my purpose in doing that is to be available to help you guys one-on-one. If you have questions with it, we can work on it together. Okay?
Thank you.
You are so welcome. I hope you have a great weekend. I'll see you next week.
Bye.
All right, bye-bye.